Alright, you guys, we got a little bit more to do here. And we're going to talk about the index of a number. And if that's small, and it is a little bit small, I'm having a hard time seeing for some reason. I didn't used to. Maybe I printed this off smaller than I normally do. But your index on a radical is right here, whatever number is here. If it's a 2, we don't actually consider it, right? Normally it's 2, but this would indicate cubed root, how many numbers multiplied by them, what number multiplied by itself 3 times. That is called an index. All right, and we're going to talk about how this index relates to a power, right? So there's a connection between the number here and a power up here. We're going to show it really quick. All right, how does that index in a radical, all right, a radican, okay, represent the power up here? So let's go ahead and look over here. They're going to say, hey, you know what? Let's take a radical sign. So let's take the square root of a and see how it represents a to the x. Let's solve this for x. Well, to do that, what they've done is they decided to square both sides. Well, the square root of the square root of a squared just gets rid of the square root and gives you a. And then you get a to the first to the second power. Well, a to the first to the second power is just a to the second power right there. Once you know your bases are equal, right? Once you know your bases are equal, all right. Oh, I'm sorry. There's a k in there that I haven't seen. So that's 2k, right? So that's a to the k to the second power. That's a to the 2k. So now we've got a situation we got with a radical, and it's a to the first power, and that is somehow equal to a to the 2k, so we got to solve for k. And if these two are in fact equal, then your exponents of 1 and 2k must be equal. If I divide by 2, k is 1/2. So what that tells us is this. It tells us that a number to the 1/2 power is equal to the square root of the same number. So this is a square root. That is interesting, right? So that means this, what do you think? That would be a cubed root. All right. So you come down here and we do it. All right. So when I come down here, if this says 64, right, to the 1/3 power. So what you do is you say, hey, you know what? What is 64 to the 1/3 power? Well, let's break it down. Let's see how many times a number goes into this. And look at that. It really says this. This is the cubed root of 64, and 64 is 4 times 4 times 4. Cube root says, what number 3 times makes 64? Well, your answer is 4. All right. What about this? All right. Convert to radicals. Well, if this is the 1/4 power, right, that is 81 to the 4th root. And this is the 1/2 power of 9. That's the square root of 9. Well, 81 is really 3 to the 4th, and 9 is really 3 squared, right? So the square root of 9 is 3, right? Remember, you've got 2 here. You're looking for 2 of the same. And the 4th root of 81 is 3. And then we're adding those. 3 plus 3 is 6 in this situation. All right. I'm going to just peek at the next page and do these. Here we go. We're going to do them. So this says 1/3 root of 8, or 1/3 power of 8, which is the 3rd root of 8. Now watch me break this down. I'm looking for 3 like factors. I break down to 8 as 2 and 4. I break down 4 into 2 and 2, and there's 3 like factors. So when you find a group of 3, when you're doing a 3rd root, you bring one of them out like that. And this one says 16 to the 1/2 power, which is the square root of 16, plus 27 to the 3rd power, which is the cubed root of 27. And let's look for them. I see 16 can be 4 and 4. There's 2 like factors, right? So that's 4. Bring them down to 3 and a 9. Oh my goodness, look. There's 3 common numbers. So the cube root of 27 is 3, and 4 plus 3 is 7. And so far, that's it. We're going to get into the power of the power next.